So good morning. Welcome everyone to this session, and we are going to be talking about driving performance and innovation with the cloud, and we are going to learn about how an innovative company is driving performance with the cloud. The company is RateGain Travel Technologies. It offers a suite of solutions as software as service to customers in the hospitality and travel industry. So some of you might have heard of this company. They did an IPO recently. And this company is one of the largest aggregators of data points in the hospitality and travel industry. And it allows its customers to leverage its data lake, big data capabilities and AI ML to acquire more guests, retain them via personalized experiences, and maximize their margins through wallet share expansion. And so joining us in the conversation today are my guests, Deepak Kapoor. He's Executive VP and Head of Engineering, RateGain Travel Technologies. So Deepak's expertise is in building large-scale AI platforms, scalable architectures, using APIs, and new SaaS products from scratch. He's an expert in performing cloud transformations. I also have with us Ipseeta Arun, Associate Vice President, Google Cloud BU, Persistent Systems. So Ipseeta has extensive experience in strategy planning for various industries. She provides data analytics and AI/ML services to the company's customer base of digital native customers. And also have with us Abhishek Mahanty. He's the Head of Partner Engineering, Google Cloud India. He's a passionate technologist with over 20 years of experience in IT, who has worked in the past as a solution architect with AWS, HP Technology Services, and Cyme Microsystems. So welcome everyone to this discussion. Thank you for being here. So let me start with Deepak. So Deepak, RateGain has been offering services since 2004.
Yes.
And beginning with competitive intelligence price comparison for hotels. So you have since expanded your service portfolio. So can you let us know what makes your company successful?
Okay. Thank you. And thank you everyone. So yes, you're right. We started like kind of long back, and so we call it competitive price intelligence, where we aggregate data for our customers, where they identify their competition, and we tell them that, okay, this is how competition is priced and this is how you can price your services, right? And then we have another vertical which we call distribution, where we connect, for example, hotels with the aggregators, like pushing their prices, their inventories, right? And then all those things. And then again, doing kind of a backward integration that, okay, some reservation happens somewhere, you have to minus the inventory. So we provide all that channel management. And then we reinvented. Like almost 3.5 years back. So I would say previously, like, we were very transactional, that yes, you place me an order and then I deliver you either intelligence or whatever services I deliver you. But then we thought of kind of doing it more strategically, and then we started the cloud journey as well, right? So earlier, like for example, if I'm aggregating data and then I'm selling you data and then that's it, the transaction is over. But then we started putting it into a data lake, and that's where our cloud journey started. And possibly that is the point that yes, we are now so successful. Actually, like, we are kind of an innovation factory. We are innovating so many products on top of that platform strategy we started almost 3.5 years back. And again, I would say that so what happens is, I aggregate data, I put it on a lake, and then I put a warehouse on top of it. Then I generate some BI, which is an added to what I was doing earlier, transactional. And then next thing is I do AI, because the data is aggregated at one place. I can be building like so many new things on top of it, which we have built actually. So I would say, again, like luck also favored us, and then our customer trust us. And yeah, we have very good partners with Google, and especially with Media Agility. They also contributed immensely to our success. So Nirdesh is here. So thanks, Nirdesh. And yes, so a couple of factors contributed in our success, I would say. And now we are innovation factory, and we are always just looking for an idea. I have an idea, we do it. So that's what we are.
So that's fantastic. So you talked a lot about data.
Yes.
And you are a data intelligence company,
right,
if you will. So and you did mention about your data lake.
Yes.
So can you tell us a little more about your data lake and your data warehousing?
Yeah,
what are the technologies underlying it?
That's interesting.
How does it work?
That's interesting. You see, so one thing again, like, let's understand the context. Travel is possibly the widest use case possible. right? Starting from your airline to your hotel to your car rental, etc., etc. So many things are there, right? And then when I start collecting the data and when I start putting it into a lake or warehouse, possibly I'm operating world's largest warehouse, because any hotel will operate a warehouse for them, and I'm operating a warehouse for all of my hotel customers, all of my airlines, all of my car rentals at once, right? So I needed bottomless storage. Plus again, we need to be cognizant of the fact of say noise versus signal. So it cannot be too expensive technology until I come to the juice. And that's where cloud helped us basically. So we have a kind of a 4-layer stack we built, starting from the bottom data lake, which I call more of a correlation layer. That's where our data science team comes and mines the data. Because what happens is, when you're doing data science, you need to run across. Like you need to join one table, one data set with other data set with you need to join hotel with an airline with a car rental, right? So that's the difference between correlation versus aggregation. Aggregation is more of a BI, data science is more of a correlation. So we start with the lake, which we built on GCS, on Google Cloud, and then we integrated all the ingestions using PubSub. So crawling happens, different data feeds comes, FTPs comes, etc., etc. Eventually everything gets landed into the lake, which is on GCS, Google Cloud Storage. And then on top of it, we build the warehouse in BigQuery. Now, BigQuery, if you know, it's not a traditional RDBMS system. It's not a cluster of RDBMS. Basically, it's a Hadoop Spark-based system, right? So, and then again, it's like very cost-effective, pay as you use, right? So that allowed us not only to operate the largest warehouse, which otherwise would have been very difficult if we go with other kind of, say, a cluster of relationals. The other thing is cost-effective and pay as you use. It's a clear separation of storage and compute, etc. So that gave us lot of leverage. So 2 layers, so correlation layer and aggregation layer. Now, but again, we need to understand that BigQuery is not a production grade database. You cannot be doing interactive use cases on top of it, right? So that's where our next layer came, our ORM layer, the object relational mapping layer, where data from BigQuery gets enabled so that it can be served on the interactive web pages. So we bring in relational technology, Cloud SQL and other things. So what we do is raw data comes in the lake, from there it goes to the warehouse, from there the specific interesting KPIs come in, they go and land into the ORM layer, and on top of it are our products. So once we mastered these 3 layers, adding products is like kind of just an OTT play. So that's what we are doing. And yeah, it has greatly enabled our data science teams as well, because now they don't need to go and scout different FTPs and like the different kind of sources. Everything is in BigQuery, so that's their starting point. They take data from BigQuery, put it back into the BigQuery, and that's the entire pivot. We are just revolving around and around. So that has been our journey.
So if you could give us a sense of, how much data do you get every day, and how big is this storage that you have?
So so I can tell you the number of crawls we did last year, because I cannot be telling you the data because there are different kind of data, and I don't want to confuse with. So what happens is, like, we also take snapshots, we also take pictures, like we do a lot of evidence gathering for whatever crawling we do, because as a customer you can say that where did you get this data. So I'm not computing. So I will tell you the number of crawls. Last year we did 7 billion crawls, which was when April 1st till March 31st this year, and this year I will do my own assessment in coming time. But 7 billion crawls, I think it is humongous. I don't know how much Google does, but once I read that they did almost 10 billion crawls that year. So we are already at that scale. I'm at that scale, yes.
So Abhishek, how does it feel to have a customer who is so big? I mean, this is a very interesting statistic that you told us, the 7 billion crawls, and maybe Google does 10 or 15 billion crawls, but you have a customer who's so big.
Yeah, absolutely. I mean, thank you for having me here. I mean, the thing is, see, we take a lot of pride in the fact that, that we built a platform that startups can then build on top of, right? And what is really heartening to see is, people experimenting fast and figuring out what works, what doesn't, and then, pivoting in that direction. So, extremely proud of the stuff that RateGain is doing on us. And if you look at it, that's basically the whole cloud story is all about. We want customers to focus on their core business, core functionality, and not get into the engineering complexities of things. Now, can RateGain go and build their own cluster of data warehouses and all? I'm sure they can, right? But is that something they want to do? Is that something they want to focus? Or would they like to focus on their core expertise, their core business, and leave the heavy lifting to the likes of us, right? And it's a win-win, right? They do well, the customers benefit from, the functionality that they provide, and they, keep us honest, right? Are we providing the right infrastructure? Are we able to handle the scale? If they are doing 7 billion crawling, then, our systems need to be scalable enough to handle all of that as well. So, yeah.
Thanks, Abhi. So, just coming back to, you mentioned that, when you are storing all this information that you're gathering, so some of it may be very transitory. It may be only for a short while. Some of it may be archival that you need to store for a long time. So how have you organized your storage in that sense? I mean, do you have different tiers of storage, or how do you do it?
Okay. So one thing is that you have your set of questions. I have my bullet points. Don't ask too many out of syllabus questions.
No, this is pure engineering. So I thought,
good one. Yes, definitely we have. So in data lake, so if you look, what defines big data? The one thing is having small number of large objects versus having large number of small objects. So in big data, we always advise to have like kind of put all the data. You see, because it's an interesting one. Like previously I was at Maersk and then we were doing digital transformation. Then we said, okay, we are doing big data. Then people say, yaar, what is big data? वो data तुम्हारा Oracle में है, वो तुम बोलते हो relational है, इसको तुम Hadoop पे डाल दोगे तो बोलोगे big data हो गया. Data तो वही है, right? So the thing is like, what is big data? So the basic funda is, big data is not more data. In our sense, definitely it's much larger data. But actually big data is all data. So when you put all the data together, then you are able to correlate seamlessly and you are able to do a lot of AI and ML. And that's where data lake strategy shines, right? Because what happens is it's a very innovative space. Like we at RateGain, like we are innovating like anything. We are like innovation factory. So that strategy also helped us, right? So what happens is when you're innovating, you don't know in which direction you might want to mutate, right? So you want to be agile. You want to be experimenting. Now what happens is, if you have your data and if you commit it to some structure very eagerly, then also your thought space gets limited. But in data lake, what happens is, you don't define schema, but you define a meta schema. That yes, this is the data landing from here, this is the bucket structure, this is the folder structure, from there on it goes here. So the lineage is possibly not at the record level, but lineage is at least at the generational level, that how it is progressing in its own genome, right? So that's how we do it. So as I said, our primary integration is PubSub, and also PubSub is fascinating, or cloud itself is fascinating, especially for travel tech, because as I said, is a kind of a very wide use case. So we need to be having much global endpoints from where we can bring in data and intelligence and publish the intelligence or whatever we want to publish. So that's where systems kinds of PubSubs, system kinds of GCS, or things which are like globally accessible, they really help. So we get data, then we store it, the raw format, and then we process it, we bring it to a structure, and then we commit it to the BigQuery, and then from BigQuery, the higher processing, the aggregation of KPIs, or the correlating it with what data science has figured out, aggregating it with the kind of dimensions which users have wanted, or different kind of viewing of that data. So that starts. So it's a very multi-tiered and kind of a multi-partition strategy at different levels in the stack we have.
Thank you. Very interesting. I think it's a very novel kind of architecture that you built. And so which brings me to the question that, what kinds of cloud solutions did you consider?
You asked me?
Yes.
Okay.
Where did you consider when you envisaged or you visualized this kind of a architecture?
Right.
So what kind of solutions did you consider which could fit your requirements?
Okay, so the word you use, fit your requirements, I think that is the crux, and that's where cloud shines. Because when you are innovating, frankly you don't know which direction you might go. So you might start with RDBMS, you might end up with a NoSQL, and then eventually you might think, no, I need a GraphQL, that kind of experience. And that kind of experience is possible, or quick experimentation is possible on the cloud. Because you don't need to be kind of setting up a cluster and setting up in Hadoop and taking 2 months, and then later on you figure out, this is not something we need. So one thing is, being cloud native really helps, and if you are not cloud native, which is okay, still you can chart out your transition path and you can get on the cloud. Now, if you are on the cloud, again, don't be confused. Try to be as much on the PaaS. Don't try to be too much on the infra side. Though we are compelled to use infra, but if I put it in a bell curve, I would say infra is on the one tail and the other tail. So this tail is the legacy, like applications which cannot be ported to the PaaS, like there is no comparable PaaS. Then you are forced to take an infra. Or sometimes you are innovating, the other side of the tail. Again, there is nothing comparable. But you should challenge yourself that, okay, why you are not finding something comparable? So you try to be as much on the PaaS. That's the first or the second thing. And the most important is, if you decided to be on cloud, then don't fool yourself by trying being open source on the cloud. What happens is people say, no, today I'm using Google, tomorrow if I have to go to AWS, third day what I have to go to the Azure. Boss, you please think first, you decide one cloud, and then you go and build cloud native, because that will save you hell lot of gluing and kind of interconnecting and then inefficiencies. So I would say cloud is the greatest thing possible for especially anyone who wants to kind of innovate. If on the cloud, be as much on the PaaS, and then again be that cloud native. Tomorrow you might go to AWS, today you are on Google, no worries, call AWS, they will help you to transition out, vice versa as well. But be on the cloud and be on the cloud native.
Thank you. I think that's some very useful advice that you've given, that, don't try to do everything at the same time. Then you might end up building more inefficiencies into the system and not really getting anything done. I think, thank you. That's very valuable advice that you've given from your experience in doing this. Ipseeta, I want to ask this question to you, that how did persistent systems help RateGain to make the decision to move to Google Cloud Platform? So what did you do?
Thank you for having me. So we have had a long and exciting collaboration with RateGain over the years. It started out with a broader conversation around which cloud do they need to move their infrastructure to. It was a strategic decision that they needed to make, and we helped them on multiple fronts. The core objective being, how do we help RateGain design more robust machine learning and analytics products? The way we went about it, we started with a hackathon event at RateGain's office with the development team to build familiarity with GCP products and understand what really works, what are people comfortable with. There was a joint strategic imperative also to evaluate whether there are any real business benefits from the migration. So there were 3 benefits we were aiming for. One was performance improvement, second was removing data silos, and third was reduction in costs. On all 3 fronts, we executed POCs with RateGain's team, and also evaluated applications through performance, latency, capability testing. Post the exercise, the results have helped RateGain decide whether or not they want to migrate. And we did execute the migration over a 3-month period. The core benefits that came out, one, we created a system wherein there were no data silos, so there was a quicker frequency of decision making possible on the business side. So accessing and updating data typically takes a lot of time, especially when you're integrating throughout the spectrum, correlating measures and figuring out whether or not to take a particular product to market, or what are the client side you want to be on. So removing those latencies helped. The second thing was there was significant performance benefits through GKE, Kubernetes. And thirdly, there was a cost reduction of roughly 15 to 18% on the infrastructure side, which was a massive amount.
So, Ipseeta, you mentioned that it took around 3 months to do this exercise, of doing the POCs and the evaluations and everything. How long did it actually take to then transition once the decision was made?
Oh no, the migration period was 3 months.
Oh, the migration period was 3 months.
Yes.
Okay. Oh, that's quick. But did it involve any kind of, say, re-engineering of the product itself to take benefit of some of the features and functionality that are provided through GCP?
There was an amount of re-engineering involved as well, so we do help on that front through our application development teams, app modernization teams. So GK being a significant component, we needed to understand how to break out monolithic application into microservices, existing microservices, how do we port them to GK. So there was significant re-engineering involved.
So Abhishek, then do you have some kind of automated tools to do some of this stuff? I mean, how do you do it so fast?
Oh, yeah, I mean, tooling is definitely one of the most important aspect of it. So whenever we get into any of these migrations, right, we run a lot of these assessments. Basis that we are able to sort of figure out what's the overall application landscape that's going to look like, right? What are the dependencies, upward, downward, and all, right? And basis that we come up in terms of, okay, which are the applications that we need to target first, which are the ones that need to move together, right? So much of that goes in there, and then comes the actual, the migration part of it, right? And that's where, the tooling on the bits and bytes come in. So if it's a database, how do we migrate it? If it's a server, how do we migrate it? If we're looking for a VM migration, how do we go about it, right? So there's different tools to help those as well. And then finally, there's a set of tools also that sort of, gives us those metrics in terms of, where we are with it. What's the performance that we were getting earlier, what's the performance that we are getting now, right? And at the end of the day, that's the data that sort of lets us know what works and what doesn't, right? And that's why customers are confident to try out cloud as well, because it's not my opinion versus someone else's opinion, it's the data that speaks at the end of the day. And when you're experimenting, the cost to fail is very less. You've not sort of committed a big chunk of your money and then you realize that, okay, this is not working out. So it's, easy to try out something and then take a call what works, what doesn't. If you've got 100 applications, do all 100 need to be on cloud? I would love to say yes. But if you feel that maybe 80 makes sense, then by all means.
Thanks, Abhishek. So, Deepak, I want to ask you a little bit about this migration to the Google Cloud. So, what was your experience, and did you encounter any hurdles that you need to overcome?
So, one thing I would say, honestly, yes, we listened to them, but we charted our own journey, right? Because what happens is, it's good to take general opinion, but always like you have to kind of cut it and polish it and make it fit into your solution space, right? And that's the one thing. Now again, as I said, we are innovation factory. We have built so many AI products, at least 3-4 large AI products we built in last 3 years. And actually our speed has been increasing. So like we took about a year to build first product, and then say every 6 months we are shipping another one, and then every 3 months that's our plan that we ship out an MVP. Right. Now if you specifically talk of, for example, we have one product where we can predict the travel demand till up to a zip level, a zip code level, right, at a hyper local level. So now hotels can use it to price their inventory accordingly, right? Or airlines. Then we have another product where we predict the air traffic forecast, we call it. So that's like airline prediction is a bit different from hotels, because in hotels like you are just destination, and airline to and from. You have to also, and then that product is also used by not only by airlines but also hotels, especially hotels which are say in AeroCity, right? And then retailers are very interested, for example, because an airport is nothing, it's like kind of a mall, right. So they count the footfall. So many interesting things we are doing. Now on that, specifically on the migration and the AI ML, I would bit differ from what earlier panelists said. You see, AI and ML technology space is still not settled, and because the nature of a data science job is mostly desktop driven. Like it's a very individual experimentation. It is not a kind of an application engineering where say there are say 4 screens and like the 4 different people are working on a screen each, right? It's like person is getting data, access to the data, doing feature engineering, and then modeling something, and then they debate, and then eventually it gets into the production. So what we need is more of an automation that yes, once he has settled on say this is the right model, and now let it go to the repository, let it get to the deployment, and then do an ML ops around it, versus core data mining activity, which still remains and possibly which will still remain kind of a very, unless it is an unsupervised situation where like you just kind of do clustering and etc. Those kind of things. So yes, so we had our own, so we have like good suggestions from Google team and media agility team. We continue working on that. Definitely we have brought in visualizations which helps data scientists visualize the data, but still most of the model development still happens in the Jupyter notebooks, etc. And yeah, and possibly in my opinion it might continue being like that, because the nature of job is that yes, it's very much individual experimentation oriented. But yes, definitely we can bring in, and we have brought in platforms on top of it, data scientists play, and mature engineering practices post their modeling is done. So those things we have brought in.
Thank you. So Abhishek, since a company like RateGain is basically an information company, they have a lot of data, they have a lot of information, and so then then the question always comes about security. How do you safeguard the applications, the systems, the data, everything? So how is Google helping in that area?
No, absolutely. I mean, security is job zero for us, right? So, the whole platform has been designed, keeping security, scalability, and, multi-tenancy, in mind, basically, right? The way we look at it is essentially, we've got something called the invisible security model, which essentially means that, bake enough security into the platform. So customers then don't have to put, additional controls on top. Of course they do, and we provide all of those controls as well. So for example, if I look at the platform itself, right, the hardware is all controlled and hardened by Google, right? Any application binary that runs on the infra is deployed in a very secure manner, right? We take an approach, which is trust nothing and validate everything. Which basically means everyone and everything sort of operating with various services gets authenticated, gets validated. The data is automatically encrypted at rest. The communication over the internet with cloud happens on an encrypted channel. The whole scale of infra allows us to absorb denial of service attacks and deal with it, right? And then of course we have a 24/7, 365 days a year sort of threat management team there as well, right? And while I say this, we work very closely with third-party auditors, even government, to meet our compliance requirements, right? So for example, in India, we've been audited by Ministry of Electronics and IT, for example, right? So that's part of it, just the foundation part. On top of that, we also offer a number of security solutions, right? That focuses on protecting, the workforce, the workloads, even the workplace, right? So you've got solutions like Titan security keys to mitigate risks from phishing, reCAPTCHA enterprise to thwart any risks from bots. You've got Cloud Armor to defend against denial of service attacks. Google Workspace, right? It's pretty secure that way. And then in terms of workplace, they have Beyond Corp Enterprise, right, which is a zero trust platform, right? Plus, on top of all of this, we've got a strong ecosystem of partners to support, right, who complement the offerings that we provide both as part of the platform and the other solutions. And these are all, across different buckets, be it governance, endpoint security, network security, everything, right? So if you look at it, it's a very comprehensive security play looking at, complete end-to-end protection. And what we see today, right, I remember, 12, 13 years back when I was starting off in the whole cloud space, security used to be one of the inhibitors, right? But cut to today, it's acting more and more as a driver, right? Because customers also realize that, there will always be, few hits and misses here and there, but more or less overall security posture gets increased. And they realize that, once you put something into the platform, we don't sort of differentiate between customers, right? Anything good that goes into the platform, every customer sort of benefits out of it.
So Deepak, you have any observations about after putting it on the Google Cloud platform, is there been any enhancement in your security posture or your confidence in security?
Oh yes, yeah. So so we are like almost like kind of fully watertight, and then like multi-factor done for any, especially any cloud resource access. It has to go through any server. So I think we are best placed. So nothing like that. And then again, the other thing which we did on top of it is, other than deploying the tools, we also designed our network so to prevent any horizontal spread if it happens. right? So someone might get an access to a server, but how to best contain it? So you can't move laterally. So the network isolation is something which is really, I think any large and especially the wide use cases like we have, I think that's what required for us, and then we designed for that. We are well prepared.
Thank you. So Ipseeta, final question to you, that what is next for RateGain? What do you see on the roadmap? What are you going to do next?
That's a very exciting question. A lot of RateGain's products are industry leading, be it the hotel segment or the airlines revenue forecasting segment. Our job as a partner is to figure out what is the best way to get a product running in an MVP format and help RateGain scale quickly and see whether it's viable in a particular market. To this end, we help them decide based on a variety of different models available on Google Cloud. Let's say there's BigQuery machine learning models available, and there are custom models available that can be leveraged. What is the best way to decide to build a product? If the data is stored in BigQuery, can we leverage BQML to create another column within BigQuery to store the results of a decision-making model and automatically update, let's say, a recommendation model being shown to the client? A variety of these permutations and combinations will help RateGain decide what is the best performing model for a particular scenario and scale it across multiple use cases. And as they launch products, maybe on a monthly basis from now onwards, looking forward to tying together our capabilities into that cycle as well.
Thank you, Ipseeta. And I think we've sort of come to the end of the time we have for this session. I want to thank all our panelists, particularly Deepak, for answering out of syllabus questions.
No, that's okay. That's very good. So I just want to make one observation, if you allow me. So you see, I must believe that we all are aware of TOGAF, right? And in TOGAF, like we used to hear always, at least I always used to hear term like ABB, SBB, architecture building block, solution building block. Like we used to like scratch our head, what is this all about? I think cloud is that Lego box which brings different ABBs and like specific SBBs, where we can just play it out and then experiment and then create the shape which we want. And yeah, I think that's where I think Ipseeta is also like referring to, can we shift our data science from Jupyter to more of their platform, but that is okay. But I think cloud, for anyone, cloud is that box which brings all that ABBs and SBBs. Now it is up to the creativity and then what market asks, that we can be creating a lot more shapes out of it.
Thank you, Deepak, for that really vote of confidence in using cloud and building blocks. So we look forward to many more exciting products from RateGain.
Right.
So thank you so much for being here. It was wonderful having you, and I think we had some great insight. Thank you.
Thank you so much.
Thanks, everyone. Thank you.